Good morning all. Today I fancy playing with a gadget, and it's the Eachine Touch T100 AC/DC multi-chemistry charger cycler. So this is a battery charger for lithium ion or lithium polymer packs typically used in radio control equipment. Now this unit has been sent in to me by Banggood, and I'd like to say a big thanks to Banggood because they're probably, from my perspective as a YouTuber, the easiest company to work with. No hassles, they make interesting suggestions for products I should try. So thank you, Banggood. Okay, let's take a little look around the box. Safety stuff. It's vital that the T100 be used properly. Lots of stuff about what it can do. LiPo, LiPo, NiCad, nickel metal hydride, lead acid. 11 to 18 volts DC on the input, that's very good. 100 to 240 AC, maximum 100 watts, maximum 7 amps, and stuff like that. And on the back we have some sockets here. The mains input on a figure of 8, DC 11 to 18 volts on a DC jack, temperature probe socket there, color LCD touchscreen, 4.3 inch, and here are some more of the spec. But I think that stuff's on the back of the unit anyway, so let's get this thing open. Okay, inside, manual, charger, and some leads. And we've got this one, banana plugs to, I think that's a Dean's, is it a Dean's? And then a Dean's to XT60 adapter there. Mains connector, that's US, so I won't be using that. And this is, battery clips to a DC connector for the DC input on the unit. Let's get the unit out. Big warning strip here. Read manual before use. Read warning before use. So here are the sockets I was talking about. Mains, DC input, and the temperature probe socket. The outputs are two large 4mm banana jacks, and the connectors for balanced charging. There's a fan in there, and then there's a little bit of spec on the back. Useful markings here: DC 11 to 18 volts input, center positive. It's important that you know what the polarity is, output and balance sockets. So here we've got 100 to 240 volt, 11 to 18 volt input DC. Charge current range is 0.1 amps to 7 amps. Discharge current rate only goes up to 1 amp, of course, because you've got to send the heat somewhere, and of course it's just dispersed internally in the unit. Current drain for balancing LiPo is 300 milliamps. No, that's not right. 300 milliamp hours per cell, is it? It's 300 milliamps per cell. Nickel, cadmium, nickel, metal hydride up to 15 cells. Lithium up to 6 cells. And lead acid 2 to 20 volts. So that's 10 cells. So as I always say, I don't really, don't take it apart, turn it on. So we need some DC power. So this is from my solar power system. 13 volts at the moment. That's going to go in there. And it doesn't fit because mine is a 2.1 and this is a 2.5mm pin. And that does make sense because this thing can put out 7 amps. Not quite sure what it would be drawing on the input while putting out 7 amps, but yeah, 7 amps actually for 6 cells. That's about 18 volts. That's going to be like over 10 amps on the input. That's a lot. Anyway, just need to get a converter for that. Right, I think this wire should do it. That I think is a 2.5, so that should fit in there. It does, and that's a 2.1 gender changer. And it powers on, and it comes on, and it's nice and colourful. And we've got a graph here with a bar graph running beneath it, so that's presumably going to be for the milliamp hour count. These look like live fields for temperature, current, and power. Buttons here to go into various modes. Also tells you a little bit about what mode it's in. It's in 3-cell. Charge current is 7 amps. That's going to be a bit high for my battery. It's LiPo. At the moment there are some memories. There's a peel sheet there. I should pull that off actually. In fact, let's do that now. Okay. What else we got? We got some stats here. Time, input voltage is my guess. Output voltage, AVE, average something, and gap. And it shows the number of cells that it's currently set to. So let's get a battery pack and do, I don't know, something like a storage charge maybe. So I'm going to use this 3-cell LiPo, nominally 11.1 volts. It's 1350 milliamp hours, so I can charge it at that current, 1350 milliamps, 1.3 amps. That would be charging it at 1C. It's got a balance connector, 4-way, obviously for a 3-cell, and a main connector, which appears to be a JST. Now I also have this JST to XT60 converter, so let's put that on. And then the charger comes with an XT60 to Dean's converter, I think that's called Dean's, and the lead supplied is then Dean's to 4mm jacks. So there's a lot of interconnections to get to these banana plugs. Right, so that's the LiPo pack connected up, the balance lead into the 3-port balance connector, and the banana plugs to positive and negative on the output. Just check polarity there. Yep, that looks good. Now 7 amps is no good, that's way excessive. So let's press that, and here's the current set, and that's 7 amps, so let's press the minus. It's a bit fiddly. If you press and hold, it is a bit quicker. So I want 1.3 amps. But I've got to get bang onto that rather small button to get it. So that's 1.3 amps. Discharge current is set to 1 amp, that's fine. Enter. Okay, let's just check these settings at the bottom. It's LiPo. We're charging. I suppose I could do a storage charge there. Store is at the top. Okay, so we're doing a storage charge. That will charge this to, or discharge it, depending on what this is currently set to its sort of mid voltage, so that you can leave it for long periods. It's a 3-cell, 11.1 volts nominal, yes, check. Charge current is 1.3 amps. Now we've got a settings menu here. Lots of stuff here. Temperature cutoff, capacity cutoff, the buzzer, the brightness of the display, the waste time between charge and discharge, input power, low cutoff. Let's have a look at that one. So it will cut off if my input goes down to 10 volts. Well, that seems fine. What else we got? Nickel metal hydride and NiCad delta peaks. Check time for LiPos. What's check time? Currently 10 minutes. Not entirely sure what check time is. Won't worry about that for the moment. So I should now be able to start. And away it goes. Oh, fans come on, I can hear. Haven't got any current yet. We've got some cell voltages, that's nice. 3.93, 3.93 and 3.96. Those seem quite well charged. So is it discharging? Does it actually tell you whether it's charging or discharging? My input voltage is 13. Yeah, that corresponds with my output voltage, 11.8. Average cell voltage, I presume that is 3.94. And the gap between the cell voltages is currently 30 millivolts. So it'd be interesting to see how that changes as you charge the unit. But I can't see at the moment whether it's charging or discharging. Now, what are these graph elements? Let's get my pencil here. Right, we've got a purple line here. That could be power, possibly. There are purple numbers up the right hand side there, but there's also, well, that's sort of pink and that's purple. Purple is 49 degrees, that's presumably the internal temperature. That seems to have got very warm very quickly, not quite sure why that is. Current doesn't seem to be on the display, unless it's so small you can't see it. Yes, there are numbers here, 2, 4, 6, 8, 10, so that's presumably amps, and we're well down the bottom because I'm doing a discharge. So perhaps I'll switch to doing a charge. Now I thought at this point I'd dip into the manual because we've got all these warnings, read manual before use. And the manual's pretty good, but there's very little text in it. It's just a whole series of pictures. Main interface, charging interface, charging parameter memory, not using the memories at the moment. Charging parameters, charging type selection, nickel metal hydride, charging types, charge mode selection, select the number of cells. I mean, it's all pretty intuitive. And in fact, I haven't had to look at this in order to get the thing doing this balance charge. No, storage charge, that's what I'm doing. Lithium battery detection time settings. Lithium battery detection time setting. Not sure what that is. 10 minutes. So yeah, not much in here at all until you get right to the end where it says, this is a professional radio control model battery charger. Please view the manual before using. If you are a fresh man, I am, please read this entire operating manual completely before using. Some warnings and some stuff. Now I'm doing this storage charge, but the voltage doesn't seem to be moving. I think that's voltage, the blue line. It's set to 11.7, a little bit above the nominal voltage. And I can't find anything on here which says what the target is. Where's it actually headed? With something like the Turnigy, these units with 4 buttons and this alphanumeric LCD display, this one, I remember, does tell you the target voltage. It tells you what it's aiming for. But this one doesn't appear to, so I don't quite know where that's headed. The only thing that appears to be moving is the internal temperature. It's coming down because the fan's on. It does seem very high though. So let's put this in a discharge mode and see if we can see a bit more about what's going on. So I've stopped it. I want to do a discharge, and I'm going to do it at 1 amp. That's the maximum this unit can cope with. That should send the internal temperature up, because when you're discharging a cell, these units aren't clever enough to discharge it back into the source supply. They just discharge it into resistors or MOSFETs or something and warm up all the internal heat sinks. So let's see what that does and how many watts we dissipate. Well, we should get about 1 amp, 12-ish volts, 12 watts or something like that. And that seems to be away. Wait for some stuff to appear on the display. And where are we going to take the voltage? This is LiPo, so it's not going to take the cell voltage below. Well, I don't know. Again, I'm not entirely sure. The manual doesn't seem to tell you this stuff. So what's it going to take it to? 3 volts or a bit below that possibly? The output is currently 11.7. Let's just wait till the display fills up and see what we get. So in this discharge mode, we've now got a screen full of information. There's not a lot to see here. The voltage has dropped down a little bit. It's at 11.6 volts, but it's probably going to take quite a long time at 1 amp for that to start to drop significantly down. We've got 30 millivolts between the cell voltages, so it's reasonably well balanced pack. It's currently discharged 44 milliamp hours. So I think actually what I'm going to do now is switch to a balanced charge, because I'd like to see if these icons change color or something, perhaps when the balance circuits are being switched in and out. I think that'd be quite interesting. So let's now switch to a charge. Actually, I'll do that now. Let's stop that. Put that into a balance charge. No, that's fast. Balance charge. So balance charge, 3 cells. Charge current is the 1S charge current. I think that's ready to go. Some of the beep noises sound very similar to the Turnigy or these IMAX ones. Okay. Big spike in something. Something's climbing up very rapidly. What's that? Oh, I think that's the current being ramped up. The green bar doesn't look very green. The yellow line at the bottom is because I've got no external temperature sensor. The internal temperature just seems to sit at around 50 degrees. How can that be? The current and the power have ramped up and are now sitting fairly flat. So let's wait until this gets a bit nearer to a full pack and see if there's any change to the display. Yes, now I've just noticed that you can turn on and off these flags, which is quite nice. Since I haven't got an external temperature sensor, I can turn off the yellow flag, and it also takes the yellow line off the display, which makes it a bit easier to see what's going on. You can do that with all of them. You can just, so that's the voltage, that's this one up here. That one appears you can't turn off. But so yes, I'd like the current and the power. Yeah, that's rather good, isn't it? Just thought you might like to have a bit of a closer look at the display, so I've come in a bit closer. I think I can peel that warning sticker off now. Don't really need that. So yeah, we've got indicators here which seem to go from 0 to 100 in 3 different colours. So that's for the external temperature, internal temperature and power, I think. Current is indicated between 0 and 10, that'll be amps. Voltage is the blue, so that's between 0 and 30 volts. That's currently 12. The pack voltage is 12. That's stepping up just a little bit. That is blue, despite the fact that it appears to have gone green where it's hit the graticule. Green and purple are these two here. So how are we doing? We're at 4 volts on the cells with a 20 millivolt discrepancy between them. Average voltage is 4.01. Pack voltage is 12 volts. Input voltage is 12.1. That's because I'm pulling a fair bit of current from my solar power system at the moment. Interesting. Let's wait till it starts getting into the balance zone. What's that? 4.2 volts, isn't it? So I've just been watching this for a while. I noticed that the gap has now dropped to, well, it was 0 millivolts, so there it is. So it's completely balanced at this point. But these icons haven't changed colour or anything, so I don't know whether it would start balancing at 4.13. It probably won't until 4.2. I also noticed that the resolution of the pack voltage is fairly coarse, so you don't really see much change as it comes up. That's now at 12.4. It's going to go to 12.6, which is 3 times 4.2. So I don't think we're going to see much change in that voltage line. I'm also waiting for this to hit the end of the screen to see whether it rescales the screen and you can continue to see the whole graph, or whether it just starts scrolling, possibly. Don't know yet. And again, current and power, there isn't a huge amount of resolution in these graphs. Right, I must have blinked because the time axis does appear to have rescaled. I can still see the start ramp there, and it's now showing a scale up to 16 what's that, minutes, I think it is. I'm getting quite close to individual cells hitting their maximum voltage. We're actually at 12.6 on the red output voltage. Now would that normally read high or low? That would normally read low, I think, because of current in the main connecting wire. But anyway, we're now reaching 4.2 on individual cells. Now I'd expect to see the current, the overall pack current, start to drop away quite quickly, because the pack voltage shouldn't go any higher. 4.2 now across the board. Let's see what happens from this point on. Right, now I can see that current is dropping away. That's down to 0.7, and of course correspondingly power is dropping away because we've got a constant voltage now. This is the CV phase. I haven't seen these icons change for the balance circuit, so I still don't. It's so well balanced, it's 4.2 across the board. I don't know whether the balancing circuits have actually come in or not. I'd have to actually unbalance the pack. Perhaps I'll do that a bit later on, to watch the balance circuits switch on and off. If indeed this shows that. It may not, I don't know. The manual doesn't say anything about it. Yeah, so we must be approaching the termination now, as we run from 1C down to probably 1/10 of C, which would be, what would that be, about 0.13 amps, 130 milliamps, and then it should terminate. Let's just wait until that happens. It's interesting, there's not much resolution on the current display, it just says 0.3 amps, but you can see that the watts is dropping, so there must be some more resolution on either current or voltage internally. because the calculation of watts is changing. Oh, the current has now changed to 0.2 amps. I could have done with an extra digit on the current display, a bit more resolution on that so that we can see what's going on. But that should terminate pretty soon now, I would imagine. Should be set for a tenth of, well, either a tenth of, well no, it's got to be a tenth of the initial charging current, because it doesn't know what C actually is. Unless there's somewhere where you can put in the pack capacity, but I don't think there was. Don't remember a menu for that. Well, I'm hoping to catch the termination of this pack balance charge on camera. If I carry on rabbiting on enough, hopefully that will happen. Now actually, thinking about it, oh, we're down to 0.1 amps apparently now. Should be pretty close to terminating. Tenth of 12.6 is 1.26 watts. So perhaps we're waiting for that to hit 1.2 watts. Battery full. Excellent. Enter. And that's it. It's done. Now, does the graph carry on running? Probably not. There'd be no reason for it to do that. But we didn't really see the balanced charge circuits activating, if indeed it shows that. Right, so that pack's fully charged. Now I can unbalance it by, I don't know, sticking a little light bulb or something across a couple of the balance charge lead connections. So maybe I'll do that. But I think now it's time to put a screwdriver to this.